All right, guys, here's your recording for Algebra 2 for your work for today. Let me go ahead and share screen so that you can see what we're going to be doing. We're going to review some of the basics of what we have already done so far with matrices, but we're also going to add pieces onto it. Sorry. There we go. Okay. So we're going to review operations with matrices, but we're also going to be introducing today what's called basic matrix equations. So I know I mentioned before that we may not have a variable, right? We're not going to have letters, but we're actually going to try these letters with solving for basic x and y. So we'll introduce it. So that starts with number 2, but I want to review something for number 1, especially if I give you more than one matrix to work with. So as a reminder, to add or subtract matrices, the dimensions have to be the same. Remember, when we talk about dimensions, it is important that we do list them correctly. It is always rows and then columns. So that's not how you spell columns. Rows and then columns. So if I'm looking at this matrix right here, the one that I just circled in blue, right? This one, there are 2 rows and it's 1 column, right? Rows go left to right, so 2 rows and then 1 column. So that means that it is a 2 by 1. Because I am adding and subtracting all the way across, you do want to make sure that they all fit those same dimensions. So 2 by 1 here, 2 by 1, and 2 by 1. So we can do math with number 1 and we can go straight across like what it says. You have a couple options. If you can keep all the numbers straight and you know your answer is also going to be a 2 by 1, by all means, go ahead and go for it. 1 plus 5 is 6. 6 minus negative 2 would be 6 plus 2, which is 8. And then 3 plus 6 is 9, minus 4 is 5. Or if you're like, that was a lot of numbers, then really just work with the first 2 and then bring that together and then work with the last one. So again, that's what it should be. So, but you can work with these 2 together. Simplify it. 1 plus 5 is 6. 3 plus 6 is 9. And then minus negative 2, 4. 6 minus negative 2 would be a 6 plus 2, which is that 8. And then 9 minus 4, which is 5. So again, a couple ways. As long as they are the same dimensions and you know you can add or subtract the matrices together, you can go ahead and go straight across. Or if you like breaking it into chunks, working with the little pieces and then bringing it together, then break it up, do it this way. Okay. So now we're going to talk about like basic matrix equations. So for like number 2, I can see x minus a matrix is equal to a matrix. So the x is going to represent an unknown matrix. So I need to solve for it and figure it out. It is the same thing as if I were to say x, hold on, let's try again. As if I were to, okay, what is going on here? There we go. So if I said x, there we go. Minus 3 is equal to 4. And you want to get the x by itself, you're going to add 3 to the other side. So you're going to do that with the matrix. So for number 2, again, I'm going to move this matrix to the other side, right? We're subtracting, so the opposite would be to add. So you're going to add the matrix. Again, do not touch the inside, just switch the operator. So switch it from a minus the matrix to a plus the matrix. And you're going to do that to the other side. Because it is a 2 by 2 and a 2 by 2, you can add, right? Dimensions are the same. So that means x is equal to, and again, top left 12 plus top left negative 2 is a 10. Top right 2 plus top right 0 is 2. Bottom left 6 plus bottom left 4 is 10. And bottom right 5 plus bottom right 1 is 6. And that's it. That's how you solve for x. So again, it's just like if you had to kind of replace it. So again, it was an x minus 3 is equal to 4. How do you get the x by itself? You add the 4. So let's look at this next one. Number 3. You want to get x by itself, which means like if it was something else like negative 2x is equal to 6. To get the x by itself, you have to divide by negative 6. Now, We talked about last week that we're not dividing by matrices, right? And we're not doing that here right now. The -2, you can treat it like a scalar. So if you're multiplying by a singular number, or it could be more than one digit, but as long as you're multiplying by a number, that's a scalar. That is not multiplying by a matrix. So all I'm going to do is like up here to get the x by itself, you would divide by -2. You're going to take that scalar and you're going to divide the whole matrix by -2, which is as the same thing. If you needed to, it would be multiplying the matrix by a -1/2. It is the exact same thing. Again, we're not dividing a matrix by a matrix. We're dividing by a scalar. So we're kind of taking things down, we're reducing. So if you had an equation, 2x plus 4 is equal to 4y, you can divide everything by 2, which would descale it. So it would turn it into an x plus 2 is equal to 2y. That's what we're doing to this matrix. We're descaling it. So we're kind of making the numbers smaller. So x is equal to, because again, you're dividing by -2 to get the x by itself. Again, divide all four numbers, keep them like, don't change the positions of where they are. So as in top left, -2, divide that by -2 and you get a +1. Top right, 0 divided by -2 is just 0. Bottom left, 4 divided by -2 is -2. And bottom right, 1 divided by -2 is -1/2. You can have fractions in matrices. That is okay. As long as it's a nice decimal, you can also transform it into a decimal. -1/2 is the same thing as -0.5, and that's a nice decimal. So that's okay. All right, we're going to make it a little bit more complex now. So first, I want to review dimensions, make sure we're okay with labeling dimensions. Number 4, we have 2 matrices included. Remember, when we list dimensions, it is rows and then columns. So number 4, the 2 matrices involved are 2 by 3s. 2 rows were 1, row 2, and 3 columns, column 1, column 2, column 3. So 2 by 3s. All right, the first thing that we're going to do is we're going to go ahead and just scale. Again, if you wanted to see what it would look like with numbers, say it was 3 times the number is equal to x minus 2 times the number. The first thing that we're going to do is we're going to do the 3 times the 2 and the 2 times the 4. Or you could do -2 times 4, but just make sure you put a plus sign in between. That way you don't lose an operator, okay? It's not the same thing as if I make it x times that. 2 different things. So what I'm going to do is I'm just going to scale the right one by 2 and just keep my minus. If you wanted to multiply everything by -2, then make sure that when you copy down, it's x plus that matrix. So if you multiply by -2, that's what it needs to look like. Again, I'm just going to do my minus. So first thing is to scale. Again, multiply everything by that scalar. So for the left matrix with the 3, top left is now going to become a +3 because 1 times 3 is 3. Top middle, 3 times 0 is 0. Top right, 3 times 2 is 6. Then you're going to repeat for the bottom row. Bottom left, 3 times -3 is -9. Bottom middle, 3 times 6 is 18. And bottom right, 3 times 1 is 3. And that's equal to x minus. And again, I'm just going to scale by 2. So 8, 2, -10, 4, 0, -6. So then now if I'm using this, what I have above my number 4 in blue, right? I now have 6 is equal to x minus 8. So then now you would add the 8 to the other side to get x by itself. So that's what I'm going to do. Instead of an 8, it's the whole matrix. I'm going to add this matrix to the other side so that I can get x by itself. So if you had distributed that -2, you would have had an x plus that matrix, so you would be subtracting to the other side. So I'm just copying all my numbers. Nope, 6, not 16. Okay, so again, I'm adding. So top left plus top left, 3 plus 8 is 11. Top middle, 0 plus 2 is 2. Top right, 6 plus negative 10 is negative 4. Bottom left, negative 4 plus 9 is negative 5. Bottom middle, 18 plus 0 is 18. And bottom right, 6. 3 plus negative 6 is negative 3. And close my matrix, and that is my x. So it's just like solving a regular equation. It's just you have a lot more numbers because matrices themselves are involved. Okay, let's look at another one. And this one is even a little bit more unique. We have, instead of just x, we have x's and y's. So you don't have to work with the whole thing for these. What I recommend is you go ahead and one, double check that you can even do the work. So because this is a 2 by 2, this has to be a 2 by 2, and this has to be a 2 by 2. They are, so we're good to go. I'm going to compare, like if I look with the top left and the top left and the top left, there's nothing that's going to help me solve for x and y. So then I'm going to look with top right plus top right plus top right, and that will actually help me solve for x right away. So I'm going to go ahead and do that. I'm going to write it out. Remember, top left plus top left will give me my top left. So 2 plus 5 is equal to x, which means right off the bat, I found that x is equal to 7. So I still need to find a y though. If you want to, go ahead and replace the x's in your puzzle or in your matrix with the value that you just found. So I'm going to go ahead and just scratch those out. And so now I have 7s. So then now I need to find my y. My y is in my bottom left, so I can look at bottom lefts. If you wrote it before you replaced the y, you would have an x plus y is equal to 9, which then means you would once again substitute with the value that you just found. 7 plus y is equal to 9. You need to get y by itself. That means that my y is 2. Once you find your x and y and your x and your y, you're done, you're good to go. So on to the next one. All right, let me double check. All right, just making sure we're on the last one. Okay, so this one, it does involve scalars. Before we start scaling anything, double check the dimensions of your matrix to make sure you can even do the work, right? Don't spend the time working on it if, right, you can't even do it. So this matrix 2 by 2, 2 by 2, 2 by 2. So good to go. I am going to go ahead and scale. I know my scalar for the left is a 3, so multiply everything by 3. My scalar for the right is I guess the middle matrix is an x. So there's no value. We don't know it yet. So you're just going to multiply everything by x and then is equal to the matrix on the right. So the first thing I'm going to do is I'm going to scale. Again, just multiply all 4 numbers by that value, that scalar, and just keep them in their designated spots. So as in 3 times 1, my new top left is 3. 3 times 3, new top right is 9, so on and so forth. With a variable, 3 times y is just 3y, so keep it in its spot. Plus 2x, negative 3x, negative 1x, 4x. Again, all I did was multiply out that scalar. 11, negative 18, 5, 25. I need to find x. So again, look at what you have. So if I have a top left plus a top left, I have my top left. So 3 plus 2x is equal to 11. We can do that. You could do the next one. 9 plus negative 1x is equal to 5. Totally works because, again, we just have one variable. Or the other option, negative 6 plus negative 3x is equal to negative 18. All 3 of those are starting points because you have one variable, one equation. So again, doesn't matter which one you want to start with. And I can even show you, doesn't matter. 3 plus 2x is equal to 11. 9 minus x is equal to 5. And negative 6 minus 3x is equal to negative 18. No matter which one you chose, you do not have to do all 3. You should get the same answer. So 2x is equal to 8. Negative x is equal to negative 4. And negative 3x is equal to negative 12. divide by 2, divide by -1, divide by -3. And x is equal to 4, and it is the same for all three equations. So again, as long as your math is correct, it does not matter which one you use. Now, if you don't get the same answer as your partner, then somebody did something wrong, right? So help each other out, double check work. If you're not sure what the mistake is, try it again, restart over. Okay, so we found x, x is 4, we need to find y. The only part that has a y involved is my bottom right. So I'm going to do bottom right plus bottom right is equal to bottom right. So that is a 3y plus 4x is equal to 25. I know what my x is. My x is 4. So 3y plus 4 times 4 is equal to 25. 3y plus 16 is equal to 25. Minus 16, 3y is equal to 9. Divide by 3, y is equal to 3. So x is 4, y is 3. And that's it. So let me stop share. So as a reminder, remember to check the rules to see if you can even add the matrices, right? I don't want you to spend the time doing the work if you can't even do it. You have a worksheet to practice these skills. So make sure you try them, show your work, especially for the bottom ones with the equations, which were kind of new. The top ones, again, I kind of showed you how you could kind of do them all in your head and get the same answer. But definitely the new problems towards the end of the worksheet, make sure you do show your work because again, it's a new topic. But also if there is a mistake, I want to see what your thought process was to see if I can help you out. All right, guys, make sure you see me if you have any questions. All right, bye guys.